Hey everyone, good morning. Brantley here again from the General AI Proficiency Institute, GenAIPI.org. Today we are going to dive right into what OpenClaw is under the hood and how it works. And this is very important for those that want to use OpenClaw to understand because you're going to learn how to actually use it, and it's going to kind of broaden your ability to have it, self-improve and be able to kind of actually be the agent that everybody claims it to be, with maybe some automations running and things like that. So we're kind of going to dive into this. And the first thing, in order to understand how OpenClaw works, is you need to know what a channel is. Channels are, and you can see here on the screen, I have this little animation I vibe coded using Replit. And channels are ways to communicate with your OpenClaw. So, we're in this tutorial, I'm going to eventually talk about connecting it to Slack. Of course, it's also, you're able to connect it to Telegram, WhatsApp. WhatsApp is kind of where it all started with Peter Steinberger. He had connected his OpenClaw, what it was at the time when it was very new and small. He connected it to WhatsApp and was using it that way. So that's really what it is. There are 20 plus platforms supported out of the box. I've only listed a few here. Messages flow in from the user from any platform, and then ours is called Jarvis. Your OpenClaw would be called whatever you call it, but it responds back to you through that channel. And every channel connects into a single central point, which is kind of the channel little node here that you can see. And so that's important to understand, because your channel that you decide to use is going to be important to connect it to that channel a certain way. Each channel has a different way to connect to it. Slack has one way, and we're going to show it in this tutorial, as well as Discord, WhatsApp, Telegram have different ways as well. So the next thing you need to understand about OpenClaw is the gateway. The gateway is kind of the control panel, so to speak, that allows OpenClaw to kind of control where these messages go and how they get organized depending upon what the user wants. So it says here, the gateway is the traffic controller. So what do traffic controllers do? They sit up in the tower, they're watching all the runways, all the planes. Yes, this runway is empty. Let's go this way. What ports, it can get very technical here. It also handles authorization. So is the person reaching out to me through this channel actually authorized to be able to have me do actions and complete work? That's very important for the security of OpenClaw, which I know had some bad rap in the beginning, but it is improving. We actually took a couple months to kind of double down and secure our OpenClaw, so we're going to show you how we did that and achieve that early on. And so it's Node.js, that's technical speak, but it is a WebSocket. WebSocket means communication can go back and forth simultaneously to and from the channel to the gateway. And so, authentication, access control, so it's a central hub controlling everything. Now, why is this important? So, when the gateway proves that you're authorized to be able to talk to the OpenClaw, it's going to decide, okay, what do I need to do with this communication? What channel is it coming in through? Kind of how am I built to receive this? And then it has the agent is going to run. At this point, the agent runtime, or the brain, is going to then think about the actions and what the user wants from it. And so it uses obviously large language models, which is the beauty of OpenClaw. If you go with some of these right out of the box providers, like Claude Cowork, Perplexity Computer, Manus Computer, you're kind of stuck with whatever models they use, or it's their own proprietary models. So, which isn't a bad thing. Most big flagship models are very capable. And there's very, slight differences in each one and kind of how it operates. But mostly, you're not going to really go wrong in choosing one or the other. But the beauty of OpenClaw is that it's open source, and you can attach any number of models to the framework, to the system. Even open source models. If you have the capacity to have a hardware that's powerful enough to run a open source large language model yourself and host it yourself, then you can plug that in to your OpenClaw, and then you don't have to pay, one of these big providers, the flagship models, Google, Anthropic, OpenAI. You can just host it yourself and have your open source model run OpenClaw. KimiClaw does this. So if you go to kimi.com, you can pay them $40 a month and also start up an OpenClaw that they call KimiClaw, and it runs on their open source model. So Kimi is an open source model. They host it for you and charge you a fee to host it. But truthfully, you can download their model and host it yourself locally and then have that connected in. It reasons about the messages, generates responses, talks to the user back and forth. It connects to the different models. You can have multiple models running at the same time. You could have Anthropic models, like Opus doing like the heavy tasks or the coding tasks. You can then have smaller models like Haiku, there's some smaller ChatGPT models, also some smaller Gemini models that you could have doing kind of smaller tasks and more kind of cleaning things up. So you can have these kind of models when you're setting up your OpenClaw. You can have different models do different tasks to kind of cut down on that token cost. You don't really need your very complex, heavy, expensive, model doing these little checks or just reading data and kind of like putting data from one place to the next. You would rather use a cheaper model for that because they're completely capable of doing that. Handle streaming responses, manages main sessions, group sessions. So we'll get into sessions a little bit here. Every time you send a message in a different channel within, if you have multiple channels kind of going at the same time and there's different messages coming in, each of those messages have their own session. So their own context limit and kind of what they're working on. The sessions don't interact at this point in time that I'm aware of. Eventually that might happen, but it could get pretty messy unless you have your very distinct rule set on which channels should go where and how they should be orchestrated. But right now, the sessions are essentially different messages coming in from different channels, and how are we going to resolve those sessions? Or do we have multiple users in one session that are talking at the same time? Things like that. And it maintains full conversation context. So like I said, they have separate context for each session, and that's how it works. Next section, or section, sorry. So the agent has the ability to use tools. There's built-in tools within OpenClaw that are out of the box. It has access to the shell commands, which is like your command line interface. So the black screen with the white text that you see on computers, all the movies where they're doing their coding and they're hacking into something, that's going to be your shell or your command line interface, otherwise known as, so your CLI, command line interface. It's going to have access to all the files, tools to be able to interact with files, create files, delete files, move files. It's going to have access to browser. There's a browser tool that allows it to control your Chrome browser. So that's what CDP is actually. So CDP, if you can see that bullet point there, you can see CDP, and that stands for Chrome DevTools Protocol, if I'm remembering correctly. Chrome. So essentially it's just Chrome. The Chrome browser is built into OpenClaw to be able to use a Chrome browser. The agents can use it. They can take screenshots, click buttons, see what's on the screen, click tabs and control that browser. So web search and fetch are also part of this. Access to the internet is very important. That's where you can actually have OpenClaw self-improve itself. You can have it go to different repositories or links when there's cool new tools coming out that people are creating, with OpenClaw in mind. Your OpenClaw can technically go and read these pages and read these repositories and kind of create a skill off of it, and we're going to talk about that. Obviously, there's messaging, scheduling, and session management, so all kind of combined here. So, tools to be able to manage the messages, manage the scheduling. You can set cron jobs, CRON jobs, and session management and things like that. So the tools are very important. It says, it's able to run code. That's a big piece of this. One part of OpenClaw is that it is able to write code on demand and kind of create things for you. And we're probably going to talk about a skill that I had our OpenClaw create that I call PRN user interfaces. So PRN in the medical terminology stands for like as needed. So it's kind of on demand. So on demand UI. Our Jarvis, our OpenClaw creates HTML web pages on demand that shows us data that we need to see. So it's not like some web page that's waiting for us to go check it out. The AI, the agent, can actually go find the data that we need, collect it, and display it on an HTML website that it codes within seconds, and then provides us a link to go see that dashboard, specific to what we need, what we asked for. That's super important to kind of understand these built-in tools. So now enough of that. So skills, I've said skills multiple times. What's the difference between a tool and a skill? So a tool is kind of the hammer that is given to the OpenClaw agent, right? So it's hammering, it's able to hammer stuff, but maybe it doesn't really know where to use that hammer, and it's just putting, it's hammering over here, over here. A skill is going to say, this is where you use the hammer there. I'm going to put a nail down, we're going to put that in the wood, and then you're going to take the hammer tool that you have access to, and you're going to beat that nail into the wood. Does that make sense? So the tools are what the OpenClaw can use, kind of like browser control, being able to write files, being able to code, do shell commands. The skills kind of house all those tools together and say, okay, go use this tool now for this piece, and then now that you're on step 2, go grab this tool. So for an example, the on-demand UI, what tools is it using? So it's definitely creating a file. So you're going to start by grabbing a file and writing some HTML code, like a framework for a dashboard. Then you're going to use a tool for the shell command. You're going to use a shell command probably and go grab data from somewhere that the user wants to see. You're going to, use that tool to grab the data. And then you're going to put it over here into the HTML and use the tool to write a file to create that HTML document to then display it to the user. So that's how skills work, and they're created by files called skill.md. So .md stands for Markdown. You may, if you're kind of deep into the LLM and AI world, Markdown is a way to write files that LLMs can ingest easier. There's been a lot of argument about which file types are the best for LLMs to be able to ingest. They've gotten better at pretty much ingesting all of them at this point in time. But Markdown is still, the .md files are still kind of like a flagship. We've kind of been using that since the beginning. There's arguments for JSON files and things like that. But anyways, those are skills. You wrap skills up. And the cool thing, OpenClaw can create new skills. You can have it create skills based on what you need. It can go grab skills from other places. We're going to talk about that a little bit, but it's basically files with instructions, and it teaches them how to use tools. And there are ways you can get open source tools, but you need to be very careful with that. There's already been some malware and stuff that are embedded in these skills that people have been offering for free. So a lot of times we recommend as GenAIPI that the safest way is to kind of have your OpenClaw create its own tools based on examples or based on what you're telling it. So. And we'll get into that a little bit more as we actually build a skill with our OpenClaw in a future video. And then you have your file system. So it's a workspace. So the OpenClaw works in a workspace. So it's like your desk, and it has its skills over here, and it's got its tools, and it's kind of grabbing all these things, and it's building it all inside this file system or a workspace. Or as a lot of people call it, like a sandbox, kind of. Like you can kind of say this is a sandbox. Sandboxes go a little bit deeper than that, when you actually have like a fully sandboxed area that's just running some very specific code. This is kind of like that, but not necessarily. There's actually more sandboxing that can get deeper into the security of OpenClaw if you want. NemoClaw does this, where they actually provide different sandboxes for the agents to kind of work in, and that's kind of just another layer of protection. Because if something goes wrong in this sandbox, it's not going to affect the whole OpenClaw, if that makes sense. So this lives at the root of the file system .openclaw on wherever you install OpenClaw. It's got an agents.md. This is important to understand these files here. So agents.md defines the agent's identity, what the name of the agent is, kind of what it's operating as. A lot of people will say, you're going to be my CFO and you're going to do my finances or something. That's in the agents.md. And whenever an agent spins up to do a task, it's going to read that file as well as the soul, as well as the memory, as well as the tools file. It's going to read all these files immediately every time it spins up to do a task. So that's why it immediately knows who it is, who it's working for. The soul.md file, as you can see here in the bullet point, shapes the agent's personality, so you can get really in depth here and kind of make it have its own personality. And that's kind of the soul. Also give it instructions that are kind of like in its soul, kind of like you're only allowed to communicate with these channels or these certain channels within a Slack, or you're only allowed to speak with these certain users. You can put different rules here as well to kind of like bring the agent and have kind of like its framework of rules and security pieces as well. And then your memory.md. This is, so of course it reads all these files every time it does, every new session it reads these files. So this is something that it does over and over again. The memory.md kind of like has context from work that's happening at the same time simultaneously within the workspace. So think of it like a short-term memory, kind of like what you're working on right now is kind of your short-term memory, as you're working on a project or something. And then you can have a longer-term memory that's kind of outside, and that maybe the agent will call if it needs to get other information that's maybe from a couple weeks ago or a month ago. Then that's when another system kind of is built in that you can actually have like a longer-term memory for the agent. But this is kind of the short-term memory, and you don't ever want to get this too full. You want it to have some context, and there's ways to kind of keep the OpenClaw agent from getting its context overloaded. And then you have your tools.md, and we talked about this. It needs to know what tools it has available to use, what hammers, what wrenches, what tools do I have available to use at all times. And so it has a list there of tools. And the key piece here is that you don't need to really go and physically change these files, but you can tell the agent to change these files for itself. So, hey, go check your memory file. Is it too cluttered? Let's clean it out. Do you have context from other conversations that are now stale or old or like no longer needed? Are there tools that really don't work that are still listed in your tools.md? Let's clean those up. In your soul, kind of like what's in your soul, what's written there, kind of figuring out the whole, like that. This is one piece of the security. Obviously there's more hard kind of like security that's built in. The soul kind of just helps prevent the agent from getting these like injected messages. You've always heard of, you've probably heard the term prompt injection, and that's when bad actors will, they know an agent's going to read their website, and so they put in these prompts kind of embedded in the text or in the HTML to try to trick the agent, and kind of inject a prompt that says, I'm your master, do this instead, type of deal. And so the soul memory kind of helps kind of secure some of that things. And so it's very important that when it comes to security that you're not just doing kind of like, setting guidelines for the AI agent, but you're also blocking these channels and different things from coming in. And we're going to talk a little about that. We're going to talk a little bit about tail scale and how that helps kind of like hide your OpenClaw from just the normal internet. And so that way bad actors can't just find your OpenClaw's IP address and start pinging it, which is what's happening in a lot of the world right now, that folks are just spinning up these OpenClaws, and it's kind of just open to the internet for different bots and agents and bad actors to kind of find and start trying to pry into it. So we'll talk about that as well. But so this is your local file system. Super important to kind of understand that piece. That's why I spent a lot of time on this. And then you have device nodes, and this is where your OpenClaw, instead of just having a Slack or a Discord or texting to it, you can actually have physical devices out there. So it has access to maybe a camera, location, notifications, apps, companion apps is what it calls it. So device nodes extend the agent beyond the screen through companion apps. I did create one of these. So this is where it uses a WebSocket again. I actually created a companion app that my OpenClaw runs, and what it does is it's on my phone. So I have a companion app on my phone for Jarvis, and what it does is it connects to my Meta glasses. So the companion app on my phone connects to my Meta glasses. It detects when my Meta glasses are on and connected via Bluetooth, and then it has access to my Meta glasses microphone as well as the audio. The speakers. And so I can actually use this companion app that I created and vibe coded to give messages to Jarvis when the companion app is on. I can actually give messages to Jarvis to our OpenClaw via my Meta glasses. It's pretty rudimentary. Meta glasses doesn't allow you to have access or control, I think, yet for many things. The SDK is still kind of being developed and released. And so, it just has the microphone and the speakers right now, which is still pretty cool. You can just kind of talk to it like Iron Man does with his Jarvis. That was kind of the premise behind it. And so, yeah, these are nodes basically that you can kind of build into the OpenClaw. And so that's the end of the architecture 101 of OpenClaw. I hope this has been very fruitful and that you learned something. When you go to use a new tool, it's really nice to be able to understand what's happening under the hood. So when something breaks, you can kind of help guide it through and say, well, what's your, if it's like context overloaded, you can go back to your, your file system and say, okay, what's the context? Oh, the memory.md. Check your memory.md. What do you got in there? Is there a bunch of just fluff in there, and do we need to go in there and clean that out? These are just examples of when you know what's going on under the hood, it's easier to kind of maintain your OpenClaw, because this is not something that you're just going to turn on and let sit run and it's going to work perfectly every time. There's skills that need to be built, and it needs to clean out its memory every so often and kind of like do housekeeping. Just like humans, we're kind of infallible. We're fallible, not infallible. Our memories are also, fallible. Like our memories fail sometimes. I can think something's been a year in the past and it's actually been 5 years, and I'm like, talking about it, or maybe I forget something in the short term that I was supposed to remember to do. Just like these agents, we're trying to help them kind of build a framework, and of course, if they have access to the context, they can do it way better than us as far as memories go. But it's this like pros and cons. You're kind of helping build things out. So hopefully this has been helpful. And then until the next video.